Welcome to Quiz Success, India's trusted platform for IIT JEE and NEET.
Introduction. See, Mom, that giant wheel, that is moving.
Yes, that giant wheel is in motion.
What is motion, Mom?
Motion is one of the key topics in physics. Everything in the universe moves.
How?
It might only be a small amount of movement and very, very slow, but movement does happen.
But I am not in motion.
Even if you appear to be standing still, the earth is moving around the sun and the sun is moving around our galaxy.
Mom, I want to know more about motion. Please tell me.
Okay, let's go home. I will teach you about motion.
Objectives. At the end of this lesson, you'll be able to define motion, describe motion along a straight line, understand uniform and non-uniform motion, calculate speed, define and calculate velocity, define acceleration, understand the graphical representation of motion, explain uniform circular motion. Understanding motion. Motion is relative to the position of the observer. For example, you can see that an automobile is moving with respect to the ground. Different observers may perceive the motion of an object in entirely different way. Or we can say that an object is in motion if its position changes with respect to an observer. A rocking chair, a swing, a bouncing ball are the examples of things that assist motion. The Earth in its orbit around the Sun is also said to be in motion. Motion along a straight line. Everything in our world moves. Even stationary things such as your house move in relation to the Sun or to the other stars. The motion may be purely vertical, that of a falling stone, purely horizontal, that of a car on a level highway, or slanted, that of an airplane rising at an angle from a runway, but it must be a straight line. When we try to locate an object in physics, we will usually relate it to some sort of reference point. This point is usually the origin, the 0 point of an axis, x, y, or z. Furthermore, we provide a numeric representation for an object's location by placing it either in the positive direction or negative direction in relation to that reference point. For example, let's put a particle at x is equal to 0 meters. The particle would then be located at 10 meters from the origin on the x-axis. As you may have noticed, position is marked by some unit of length. The typical unit we will use is meters. Here the distance covered by the object is 10 meters. To describe distance, we need to specify only the numerical value and not the direction of motion. The numerical value of a physical quantity is its magnitude. The difference between an object's starting position and final position after it moves is known as displacement. Uniform motion and non-uniform motion. To understand uniform and non-uniform motion, let's take one example. Look at this table. This is the distance covered by a car A. We can see that in 0 seconds it covers 0 meters. In 5 seconds it covers 10 meters. In 10 seconds it covers 20 meters and so on. Or we can say that in every 5 seconds it covers 10 meters. It travels equal distances in equal intervals of time. Hence, it is in uniform motion. Look at car B now. Car B covers 5 meters in 5 seconds, 15 meters in 10 seconds, 20 meters in 15 seconds. We have seen that the car B does not cover equal distances in equal intervals of time. Therefore, it is in non-uniform motion. Speed. Now, can you tell the difference between two identical objects traveling at different speeds? Nearly everyone knows that the one moving faster or the one with a greater speed will go farther than the one moving slower in the same amount of time. Whatever speed is, it involves both distance and time. Faster means either farther, great distance, or sooner, less time. Doubling one's speed would mean doubling one's distance traveled in a given amount of time. Doubling one's speed would also mean halving the time required to travel a given distance. The rate of motion of an object can be measured by finding out the distance traveled by the object in unit time. The SI unit of speed is meter per second. This is represented by this symbol. In most cases, objects will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of their average speed. The average speed of an object is obtained by dividing the total distance traveled by the total time taken. If an object travels a distance s in time t, then its speed v is equal to s upon t. Speed with direction. Velocity is speed in a given direction. Speed describes only how fast an object is moving, whereas velocity gives both the speed and direction of the object's motion. To have a constant velocity, an object must have a constant speed and motion in a constant direction. It is calculated in the same way as we calculate average speed. It is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity by 2. Where VAV is the average velocity, U is the initial velocity, and V is the final velocity of the object. Speed and velocity have the same units, that is, meter per second. Rate of change of velocity. Acceleration is the rate of change of velocity with time. In one dimension, acceleration is the rate at which something speeds up or slows down. Acceleration describes the rate of change of both the magnitude and the direction of velocity. In SI units, acceleration is measured in meters per second square. It is a measure of the change in the velocity of an object per unit time. That is, acceleration is equal to change in velocity by time taken. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is v minus u upon t. Uniform or constant acceleration is a type of motion in which the velocity of an object changes by an equal amount in every equal time period. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. Example. Let us take the example of a racing car. It takes 10 minutes or 0.17 hours to travel 23 kilometers from start to finish. We have to find the average speed and average velocity. We know that average speed is distance traveled by time taken. Therefore, average speed is equal to 23 kilometers by 0.17 hours, which is equal to 135.29 kilometers per hour. Similarly, average velocity is displacement by time taken. We can see in the picture that displacement is 4 kilometers. Therefore, average velocity is equal to 4 kilometers by 0.17 hours, which is equal to 23.53 kilometers per hour. Graphical representation of motion. A graph is a pictorial representation of the relation between two sets of data, of which one set is of dependent variables and the other set is of independent variables. In a displacement time graph, displacement is a dependent quantity taken on the y-axis and time is taken on the x-axis as it is independent. If the position of an object changes with time, it is said to be in motion. If an object has equal displacements in equal intervals of time, then the graph is a straight line inclined with the x-axis, which represents uniform motion of the object. If the graph is a curve, it represents non-uniform motion. The slope of displacement time graph gives velocity of the object. We will go through this in detail after a short interactivity. Distance time graphs. Equation for position-velocity relation. The third equation will be obtained from these two equations. From the velocity time graph, distance travelled s is equal to area of the trapezium OABD. This is 1 upon 2 into B1 plus B2 whole into h, which is equal to 1 upon 2 into OA plus BD whole into AC. Substituting OA by U, BD by V and AC by T, we get S is equal to 1 upon 2 into U plus V whole into T, equation 1. But we know that A is equal to V minus U whole upon T, or T is equal to V minus U whole upon A. Substituting the value of T in equation 1, we get V square minus U square is equal to 2AS. 2AS is equal to V plus U into V minus U. V plus U into V minus U is equal to 2AS. By using the identity A square minus B square is equal to A plus B into A minus B, we get V square minus U square is equal to 2AS. This is the third equation of motion. Uniform circular motion. Uniform circular motion describes the motion of a body traversing a circular path at a constant speed. The distance of the body from the axis of rotation remains constant at all times. As an object moves in a circle, it is constantly changing its direction. Merry-go-round is an example of uniform circular motion. Satellites orbiting our Earth, artificial satellites or our moon, have motions that are very nearly uniform circular motion. The planets that orbit our Sun have motions that are very nearly uniform circular motion. Assessment. Now time for an interactivity. Click the correct option. Did you know? Sir Isaac Newton is one of the most influential scientists of all time. He came up with numerous theories and contributed ideas to many different fields, including physics, mathematics, and philosophy. Born in England, Isaac Newton was a highly influential physicist, astronomer, mathematician, philosopher, alchemist, and theologian. Newton's 3 laws of motion relate the forces acting on a body to its motion. Johannes Kepler helped lead a scientific revolution in the 17th century with his amazing work in the field of astronomy. Among his many contributions were the 3 laws of planetary motion. Summary. Let us summarize what we have learned. Motion is a change of position. It can be described in terms of the distance moved or the displacement. The motion of an object could be uniform or non-uniform depending on whether its velocity is constant or changing. The speed of an object is the distance covered per unit time, and velocity is the displacement per unit time. The acceleration of an object is the change in velocity per unit time. Uniform and non-uniform motions of objects can be shown through graphs. The motion of an object moving at uniform acceleration can be described with the help of 3 equations, namely, V is equal to U plus AT, S is equal to UT plus 1 upon 2 AT square, 2AS is equal to V square minus U square, where U is initial velocity of the object, which moves with uniform acceleration a for time t. V is its final velocity, and s is the distance it travelled in time t. If an object moves in a circular path with uniform speed, its motion is called uniform circular motion.
Friends, welcome to Kwiiz Success. Now, There's no need to memorize without understanding. Our innovative learning technique helps you grasp concepts easily and effectively. Here, you'll find the perfect combination of 3D animated videos, AI-powered test series, and ebooks enriched with MCQs and mind maps. We offer the foundation course for class 8 to 10 students and the success blueprint course for class 11 and 12 students, providing a real exam experience and a boost in confidence. All our courses are designed by IIT and IIM alumni to ensure top quality learning. Whether it's an engineering entrance, medical entrance, or any competitive exam, success is now in your hands. Thousands of students have already benefited and now it's your turn. Study from home, at your own time, and at your own convenience. Visit www.success.org.in or scan the QR code to download the Kwiiz Success mobile app for free. Take mock tests, practice regularly, and see real improvement in your scores. Please subscribe our YouTube channel, Kwiiz Success. Also share it with your friends. Thank you.